To this day. You've made it. Take a deep breath. It's almost over. All right, excellent. So basically the first group right now is across the hall practicing, which is what you will do prior to your presentation. So clearly you won't have anything to record notes for your presentation on. But to be sure, once you finish in there, you'll be in the hall with me for a quick minute. I'll hand you the microphones for each side. It's better if you stand to the left and to the right of the screen, not in front of the projector, because you don't have stuff in your face. That works well. And please be sure to keep the mic here, not here. Notice the difference when you don't have it. Nobody can hear you, at least not well. I'm not soft-spoken, so you can hear me, but many of you are soft-spoken, so you do want to be heard. You've worked hard on this. I want people to be able to hear what you're saying. So that being said, please try to be sure you're doing that. There will be clickers on either side, so you can change to the next slide. And you're familiar with how this is going to flow, I am sure. Take at least brief notes on everyone else's presentation so that you have an idea, because you will at some point, depending on time, it might be here, but more than likely it'll be when you get back to your home school. You'll be voting on which group, taking questions from the group, from the audience. The teachers will have prerogative to ask a question of you if they choose. But just for the sake of, we've got a lot of people to talk, we won't be able to allow audience members to ask those questions. What questions do you all have in the moment? Okay, stay tuned. I am trying to pay attention to the temperature in here. It was cold before, that it's not hot. Now it's trying to get into a nice comfortable zone. So bear with us as we sort through that, and we will start momentarily. It's here's a second mic. Don't do anything. Don't touch. Just it's ready. Just bring it back down to me. All right, ladies and gentlemen, please welcome Group 1 for their presentation for the grant.
Our topic is microbial biotechnology, and I will be introducing you to everyone today. I am Willow. This is Alyssa. This is Jasper, and on the other side we have Ben and Cheyenne. The background and foundation of microbial biotechnology lies within developments needed during World War I. During World War I, the need for acetone arose because of the use of smokeless gunpowder. Acetone was a chemist and doctor named Dr. Cham Wiesman went through and had a process called ABE, which stands for acetone butanol ethanol fermentation. He used this fermentation to convert potato starches into acetone, which again was used for smokeless gunpowder, to turn the powder into something that they could actually load into artillery. The current research around this topic is primarily medical, which made our research a little difficult because we are focusing on the agricultural side of things. The things that were agricultural were very, very academic, which only complicated things. Our project surrounds a lot of agricultural things, and we've been using this technology for centuries, which things such as bread and beer, and overall, we're all very familiar, we just don't know it yet.
When researching microbiomes biotechnology, our current actions were mainly going to be for our funding, space, and issues. So our issues with that is going to be our funding. We need to have enough money to give out to start our biopesticides to give locally to our farmers so they can do their thing with their farm so we can see the effects that we're going to have. Then we're going to have our space. We're going to need to have a university, which we chose of Virginia Tech, to see where we can get our equipment to study more and have more of their technology to advance our biotech, our biopesticides that we're going to give out locally to farmers. And then our transport, we're going to need something to have more to give out to the local farmers, having our biopesticides traveling safely so we can give them out nice and well to there's not going to be any side effects when they're delivered.
Our proposal is asking for $600,000 to build a biopesticide database that can keep track of each biopesticide that's used locally and keep track of current research on biopesticides. We will hope to achieve this locally by working with Virginia Tech's Integrated Pest Management Innovation Lab to use their resources so we can help enhance research on biopesticides. We would also like to work with local farmers and get information from them so we can help figure out what biopesticides are best for them to use while causing the least harm.
The idea of our proposal is to provide local farmers with the idea will be accomplished by providing local farmers with readily available supply of biopesticides, which will be organized in a database established with the Virginia Tech IPM, as he mentioned, the Integrated Pest Management Lab. And from there, the construction of distribution facilities will begin, and those will be based in agricultural areas. And from those agricultural areas where the farmers are shipped the biopesticides, they'll be informed on the correct or most advanced measurement and application methods for each biopesticide species and the expected effect based on current research, as well as what the scientists expect to happen when those biopesticides are used. And this is a 5-year plan of that idea, and the construction of facilities will be accomplished after 1 year, and from that point, the process will continue to further advance the research at a quicker rate. Here we have our budget and the expected cost for each aspect using the grant money. This will go with our 5-year plan. The most expensive portion will be the construction of distribution facilities, and from that point, from the point of beginning the research, it'll be 1 year from the information. The construction will be completed after 1 year, so that cost of the grant money will only take 1 year. And the next part would be the creation of the database and the overall upkeep, which would be the cheapest due to being an online database accessed by the public and local farmers. The next part would be the 8 paid internships, which would pay $25,000 a year to each member, and they would go through a selection process with the professionals at Virginia Tech to decide that. Next would be similar to what we're doing, like a grant that we would give to local farmers to entice them to be a part of this research while still remaining financially secure of their everyday activities. And that would also cover the cost of transport, which Alyssa was mentioning earlier, of the biopesticides to the facilities and to the farms. And the last part would be the individual biopesticides themselves, which would have a fluctuating cost. The market, it isn't really secure at this point, which is what we're trying to accomplish over time. And, that was kind of a rough estimate, if we're being honest, but it does add up to an even $600,000. And subtracting the costs of the construction, which will only take 1 year, we would expect that to reach over $1 million over the 5-year period, which will receive the money from alumni organizations at Virginia Tech to cover the additional costs.
Our prototype for the proposal is a database along with distribution centers that will promote biopesticides into the agricultural field. There are 3 pages on our database, the first being the homepage. Our homepage includes the background information of why making the change to an alternative source of pest control is important to combating climate change and the effects it has on the environment, as well as our mission, which is to provide local farmers and citizens with information on how microbial biotechnology is applied into the agricultural field. The second page is our current research, which includes information of microorganisms and what environments they work best in from previous research, as well as the research we will gather from our trial, which is on the third page. Our third page is the one on the screen right now that says farm-specific formula. Our trial will have farmers fill out an application that includes information of their type of soil and issues they may have had with nutrients in the soil before, as well as the history of pest control they've used on their farms. From there, the scientists will pick 4 farms from the applicants who will be supplied with biopesticides engineered towards their farms. And further down on the page, there's a progress check that will be expected to be filled out every 3 months by the farmers, updating the scientists on qualitative information such as their soil and if they've seen improvements, as well as their crops and if they've had more trouble with pests or if they've seen improvements. At the end of this trial, when the farmers harvest their crops, they will provide the scientists with their crop yield, which will be used to see if the biopesticide had a negative, neutral, or positive effect on the farm. Our grant proposal will be used to provide local citizens and farmers with information on microbial biotechnology and how it's being applied into agriculture. It will also be used to promote the use of biopesticides into agriculture as they are newly researched. But we are hoping that through this proposal, we will be able to make biopesticides more prevalent, as well as use them as a way of combating global climate change and the negative impacts it has through the dramatic weather patterns and global warming that overall affect the farmers in the long run. While this is just a local proposal, we hope this will branch out and we will be able to make biopesticides a more stable market and more prevalent in agriculture. This is our works cited. Thank you to Ms. Richardson, Mr. Hoschner, BRVGS admin, and the University of Virginia for making this project possible. Any questions?
So you guys just great presentation. Congratulations. Go ahead and tell us a bit more about why biopesticides are so preferable.
So biopesticides are more preferable to chemical pesticides or more traditional methods because they don't have a negative effect on the environment or produce greenhouse gas emissions that the traditional methods do, because it is using it uses microorganisms and other biotic factors to produce the formulas instead of the chemicals that are used in the other methods.
Thank you guys. Good job. just give us the thumbs up. Please welcome group 2.
My name's Guinevere.
I'm Dylan Butler.
I'm Isabel Ackman. I'm Kayla.
I'm Emma.
I'm Margot.
We are Group 2, and our project is on precision medicine and pharmacogenomics. Background. Precision medicine is a scientific medical field that is used to study how certain medicines react with certain gene types. It was determined in 1959 by Dr. L.Y. Way. Pharmacogenomics is a subsection of precision medicine, and it's the study of how certain genes would, could, and should react to different medicines. It was discovered in 1979 by Frederick Vogel.
Current actions. The world of precision medicine has undergone many advancements as well as received some presidential publicity throughout the last 10 years. Precision medicine has made great steps in the fields of cancer research, specifically pertaining to those of breast cancer and prostate cancer. Breast cancer, precision medicine has helped to develop the method known as liquid biopsies. A liquid biopsy is a highly sensitive blood test that, with the incorporation of gene drug targeted therapies, can locate and detect therapies within its patients. Prostate cancer, through the incorporation of precision medicine and AI, can analyze a patient's data and help to predict the cause and effect of certain genes or on certain drugs on patients. Publicity-wise, we received, I think, our most publicity in 2016 during Barack Obama's second term when he publicly announced and promoted the use of precision medicine within the medical workplace.
Compelling issue. Our issues focus on patients and their specific genes. Modern day research focuses on ethical and effective ways to gather more information for underrepresented demographics. By identifying biomarkers in diseases such as Alzheimer's or breast cancer, treatment options will become more adaptive and effective. Our issue needs more attention because not all medicine is made for one person. In the crowd, how many of you have broken a bone in your life? Usually, let's say you broke your arm. You go to the hospital, you get some medicine, they shoot medicine all throughout your body. Precision medicine is like an ice pack. You can place it directly on your arm. By using precision medicine, we can cater to more specific gene types.
Our prototype is a survey and a database. Patients will have access to the survey and they will answer the questions. Once the questions are answered and submitted, the answers will be immediately transferred into a database that is accessible by doctors to see their patients' results and by patients to see their results only. We believe this is important because it will further the relationship between doctors and patients, which is a current issue. We believe it is feasible and cheaper because it is on average more it is cheaper and on average easier for doctors. Sorry. It is on average, it is cheaper and more efficient for doctors and patients to use our database than others.
We expect our prototype to debut in Central Virginia for the first time within the next 6 months to a year. That is because our screening survey will need to be set up in medical facilities, while our database will need to be integrated into the electronic health records and in Virginia Tech's Freeland Labs, who we plan on partnering with. Once everything is set up, results from the screening surveys will be checked weekly,
and DNA kits will be sent out within 2 to 3 days of the results being checked. Patients can expect to get their DNA kits within 3 weeks of the results being checked, and their results within 4 to 6 weeks of the DNA kits arriving back at the lab. Once this goes on for around 6 months, the screening surveys will be taken down in Central Virginia and set back up in another area of Virginia. And that's where the cycle will repeat until we've reached every single part of Virginia.
For our budget, we will allocate all of the $1 million to test about 500 patients, free genetic testing kits over the course of 6 months in the state of Virginia. And that would cost a total of $840,000. $840,000 is a lot of money, but that's not including all laboratory fees, implementation into hospitals, and regulatory compliance. With the remaining $160,000, $150,000 will go to making a class for physicians, teaching them how to use the database and the importance of it, and $10,000 will go to implementing patients' genes into the EHR. Our prototype is composed of a survey and a database. The first QR code is of the survey, which teachers, if you'd like to take out your phones and scan it now, you may. All the questions on the survey are made required by default, so if you'd like to go to the next section, just put a period in it and it will count as an answer. The second QR code is of the database, which is from the medical professional's point of view. You may also scan that if you wish. Only the first row is filled out to show what it will look like when it is actually a database.
Conclusion. We firmly urge you to choose our group for the grant of $1 million over others because it will help reduce unethical bias in the logging of personal medical data. With this $1 million, we will record data and spend it on equipment and usage fees. The use of this should help us and other people in the medical field, more professional people, find cures for newer and deadly diseases. And yeah. So we're excited. Thank you to Mr. Hauschner, Ms. Richardson, the Bureau of VGS staff, and UVA for helping us with this project.
Data from these 500. What's the next step? They get precision medicine based on their
So after we collect this data, we are going to pay the $10,000 manual entry fee of their genes or their genetic makeup into the EHR, the database. And from there, we will be able to diagnose them later on down the road, using a gene drug targeted therapy. So if someone has cancer, it's a more effective way of treating.
how you're going to screen? Like, is it just first come, first serve for volunteer basis, or are you going to be interested in people that have pre-existing conditions?
I think we could do sort of like a mix of both because currently there are like cancer treatments and treatments for other diseases. Like there's a disease called cystic fibrosia, which is a buildup of mucus in the lungs, and there's no set cure for it currently. And so they've done a lot of gene drug interaction trials to try to find a way to reduce the mucus in the lungs.
And obviously, some diseases are more harmful than others. For example, like Tourette's syndrome, that's the misfiring in the brain to cause involuntary movements, and sometimes that can be deathly, like jumping in front of a car while it's moving. And some are less deadly, like cancer that may kill you in 40 years. So obviously, we're going to take the more deathly diseases first, and then allocate just down the road from there.
This is our presentation, immunotherapy via virotherapy. I'm Avery, this is Millie, that's Gino, and that's Sam. Immunotherapy is a generally new cancer treatment that has been introduced to the United States in recent years. Immunotherapy is commonly known as a targeted treatment, and it is able to basically target a certain cancer in a certain section of your body, and it eliminates it effectively and literally harmlessly. But immunotherapy and virotherapy have been around for much longer than that, though. Chester M. Southam, who is the man on the board right now, he was responsible for a lot of the early developments of virotherapy and immunotherapy in the early 50s and 60s. But he wasn't the only one who introduced this whole new process of effective and targeted therapies. A woman named He wasn't the only person, and I'm unfortunately unable to recall her name, but she also was a main contributor towards the studies towards this important and effective way to eliminate cancers. Current actions that are being done for immunotherapy via therapy are the United States first introduced it in early 2005, and even though it was introduced in the United States in 2005, it was also recently introduced into Virginia healthcare as well. According to the Virginia healthcare, there's actually been a lot of evidence that immunotherapy via therapy has assisted with the survival rates of cancer treatments and patients.
One of the critical areas of need facing immunotherapy via virotherapy is affordability. It is a very expensive medical treatment and considered not very accessible due to the high cost per treatment. People who are struggling financially or in underserved communities would have a harder time getting this type of care. Therefore, our goal is to increase the accessibility of immunotherapy via virotherapy by lowering the cost. This will be done by conducting more research, increasing clinical trials, and expanding the Jaunt Transportation Network. We will collaborate with local colleges like UVA and their Cancer Treatment Center. The first part of our grant will go to UVA to conduct the clinical trials, and the other part will go to Jaunt to continue giving free transportation to and from hospitals. When advancements are made in scientific and medical fields, it will lessen the price of that treatment. In conducting clinical trials that verify the safety and effectiveness of immunotherapy via virotherapy will lower the cost.
If we receive this grant, the first thing that we would do is set aside $50,000 to cover any unexpected costs and taxes. Then we would give money to UVA to help streamline the process of immunotherapy via virotherapy to bring down the overall cost of treatment. Then we would give more money to medical centers so people don't have to travel to major hospitals to get treatment. Then we would give money to Jaunt, which is a program that provides free transportation to patients who need medical treatment and are currently underfunded. So we would give them extra money to help cover the cost that adding more patients to that workload would add. And then we would apply for more grants to help keep the program going indefinitely. So we would ask for a budget of $1 million, with $50,000 going to unexpected costs and taxes, $317,000 to go to UVA, another $317,000 to go to building out those medical centers, and $316,000 to go to Jaunt. And with this budget, we will hopefully be able to bring down the total cost to $24,000, despite what the current cost is for all patients.
This is our prototype. So we will be starting with this is our prototype. This will be going on billboards and ads throughout regions that have higher cancer rates than normal regions. Well, it starts with an onoclitic virus right there. When it goes into a healthy cell, it does nothing. That healthy cell will stay healthy no matter what. The onoclitic virus more or less disappears, which is surprising because more or less no other cancer treatments really do this, because a lot of cancer treatments will go ahead and basically kill other healthy cells, like chemotherapy will destroy hair follicle cells, which is why most people that do chemotherapy will not have hair because of the radiation. However, with ours, it will stay healthy. But on the side of when it goes to an unhealthy cell, the oncolytic virus will go through that cell and destroy that cell, and will move on from others to other cells until the cancerous tumor is gone. From the original work of William Colby and others, immunotherapy, virotherapy was used to treat many different types of cancers, mainly cancerous tumors. We are asking for $1 million to first make this treatment more affordable while still making it a great treatment like it is today. We hope that this will be running indefinitely by adding more money after this $1 million grant if we do get it. This is our references.
So I guess clarify for me, you guys are asking for $1 million to ban jaunt and for UVA treatments.
Yes.
Okay. Okay. What about the research plan more?
Doing research or clinical trials is a very, very expensive process, which can cost tens to hundreds of millions of dollars. So the research part would mainly be contributing, not really running a clinical trial, to UVA, which is already doing those clinical trials. Yeah, through all processes, through transportation, through the treatment cost, and the distance to those centers.
Thank you. Thanks so much.
Hello, we are the Funding Our Future Group 4 project, and we are covering genetic modification in agriculture.
I'm Connor.
I'm Abigail.
I'm Anna.
I'm Cole.
I'm Aiden.
Genetic modification in agriculture first started around 8000 BCE with people crossbreeding animals. But the first it was used for research was around 1866 with Gregor Mendel crossbreeding peas. From his research, we've come up with the subject of genetics. With his research, scientists started modifying corn. In 1922, corn was first introduced to market. Hybrid corn was first introduced to markets. From that, scientists started modifying cotton, apples, pineapples, and more. In 1973, two biochemists, Herbert Boyer and Stanley Cohen, created genetic engineering with taking DNA from one bacteria and moving it to another. From their research, scientists have been able to increase the production of crop yields in modified crops.
There are a lot of misconceptions about genetically modified agriculture, partially because a lot of the public is just uneducated about the topic. People automatically assume that genetically modified agriculture is bad for you just because it's started in a lab. Another misconception is that genetically modified agriculture is bad for the environment when it's actually quite the opposite. Genetically modified agriculture reduces pesticide use, unlike normal agriculture, so that reduces pesticide runoff into bodies of water that could harm the environment. Another thing is genetically modified agriculture reduces greenhouse gas emissions into the atmosphere, which can damage the ozone layer in the atmosphere. The government cannot enforce people to try genetically modified agriculture, so they instead put programs into place like the Feed Your Mind program, which was started by the USDA, FDA, and EPA to inform the public on the goods of genetically modified agriculture. The Feed Your Mind program has helped a lot of lower income households today.
Our compelling issue is that female farmers are a minority in the field of agriculture. They generally make less than males, and we want to improve their crop yields so that they can increase their profits, and so they can be level with male profits. Virginia is the 27th state for the highest number of female farmers, with a percentage of 36.1. And on the left, there's a graph that says 50% of female operated farms have sales and government payments that are $5,000 or under. And versus males who more of them have 10,000 to 50,000 and above ranges. And Virginia female versus male farmer population, there's the number of farmers 25,000 to 42,000. And the percentage of total 37 to 63%, and there's also the approximate ratio of 25 to 42.
Our group is looking to decrease at least 25% of the prices of our crops. As genetically modified crops are becoming more pervasive around the US, our group hopes to decrease at least 50% off the total price of our crops by the end of our project. Prices will be checked every 6 months to make sure we're making steady progress. After our foundation is set, we will reach out to farmers, explain the purpose of our program, and ask if they want to participate. After that, we will reach out to Agritope Incorporated to obtain crop for maize and tomato that have been genetically modified to increase crop yields and herbicide tolerance. Agriculture runs America, and thanks to our farmers, a lot of people are able to eat 3 meals on a daily basis. However, this didn't used to be the case. As I stated, a lot of crops have had their genomes modified to increase crop yield and reduce pesticide use. And as stated, we will then sell those crops to farmers at a lower price. However, we're choosing to focus on female farmers specifically
because out of 3.4 million farmers nationwide, 1.2 million of those are females. About 36% of the farming industry is made up of females. So you'd be surprised to know that women-run farms are making 40% less than male-run ones. This is unfortunate because with inflation and prices rising, it's hard for a lot of females to stay on their feet. So if we can bring attention to this wage discrepancy, then those females could gain support, get donations, and be able to afford more genetically modified crops.
This is our timeline for our proposal. If we receive the grant, we intend to begin typical business operations and developing the organization immediately after in April of 2025. This is just writing up contracts and consulting lawyers to make sure our organization is as professional as possible. In November of 2025, we plan to have the organization fully developed with a main area of operations and everyone filling every position. By January of 2026, we intend to have the seeds fully purchased and distributed to farmers who opted for this program. And by September of 2026, the first conference is intended to be held in rural Virginia. This has us a bit of time just so we can reach out to the organizations that regulate genetically modified organisms, and so they can have their representatives flown in to rural Virginia. In January of 2029, we hope to have our expected results achieved, which is a 50% decrease in genetically modified crop prices as previously stated. We gave it this amount of time so farmers had about 3 years to grow their crops and decrease the prices in the local farmers markets. Here is the budget for our proposal. We intend to use the entire $1 million of the grant if we receive it. $50,000 will be used for the typical business operations to form the foundation. This is things, again, such as writing up contracts and writing different contracts for positions. $100,000 will be used to purchase a main area of operations and necessary technologies. This is just the down payment and rent for an area where we'll hold many things regarding this proposal. And necessary technologies is things such as computers so we can market, etc. $200,000 will go to the salaries of new members. These are positions such as the board of directors and promotional marketing. $300,000 is very necessary for the cost and distribution of genetically modified crop seeds. Reaching out to Agritope Incorporated, genetically modified crop seeds are about 70% more expensive than non-genetically modified crop seeds. Therefore, if we're going to be spending this much money distributing it out to farmers, it's going to cost a little bit. And the most money we want to spend is $350,000 on the travel and payment costs of organizations and the conferences for which the organizations are invited. This is because we want to pay the organizations to have their representatives sent in, and we also want to pay for the transportation and the venue where the conferences are held. This money is necessary because we're going to hold multiple different conferences around rural Virginia, and that money will add up.
So for our demonstration of proposal, me and my group have come up with a centralized location and office in Louisa County, Virginia. As stated previously, our hope is to reduce the cost of genetically modified crops in hopes to decrease the overall price for farmers and empowering female farmers. We would do this by partnering with Agrotech Inc., and we would do this over a few years span. And so our group, we have come up with a proposal to not just lower the price, but hopefully this program will decrease the price to implement genetically modified crops, overall increasing the amount of genetically modified crops, in hopes of reducing the wage gap between female farmers and male farmers. And by doing this, we'd not only be empowering female farmers, but we'd be setting a message that farmers across our local communities are supported. We'd be establishing a program that would partner with other agricultural industries to hopefully help us.
These are our works cited, and Thank you to Mrs. Richardson, Mr. Hausner, BRVGS, and UVA for helping us conduct this research to make this project possible. We are now open to any questions.
Love the idea. It's very layered. You've got both GMO outreach and you're fixing a statistical pay gap here. Really neat that you've got an idea of kind of testing two birds with one stone there. Tell me a bit more about the conference, you guys. What does that play out like?
I think this would. We want to bring in different organizations that regulate genetically modified organisms because a lot of the misinformation that consumers feel that they are not informed as much about is how genetically modified crops are researched and considered safe. And we want to bring in representatives from these organizations so that they can ask questions and feel more informed on the research and the study of these genetically modified organisms for safety, and just let them ask any other questions in general about genetically modified organisms.
So you have in mind basically the farmers who funded and given these seeds come here and meet with the
Yes, as well. Farmers also with the consumers, so they feel more inclined to purchase these crops.
Do you have any specific crops you're going to focus on?
Tomato and maize.
Okay, that's what I thought.
Thank
Thanks
you.
so much.
Hello and good morning to Group 5's presentation on stem cell therapy. I'm Laurel, this is Abby, Samir, Holland, Gabriel, and Jana.
In the late 1950s, George Mathey was working with stem cells and wanted to perfect a stem cell transplant. In 1963, he successfully performed a bone marrow transplant on a patient of his with leukemia. The purpose of this experiment was to find another treatment for cancer rather than chemotherapy, since chemotherapy kills cells in the body. Stem cells are found in every organism and they help repair damaged tissue throughout the body. When those stem cells no longer function properly, that is when a stem cell transplant is necessary. Stem cell transplants have helped patients overcome blood diseases, nerve diseases, and heart diseases. As previously stated, in modern medicine today, doctors and scientists are trying to find another cure for cancer rather than chemotherapy. Mesenchymal stem cells are from the blood, and they have anti-inflammatory properties and suppress tumor growth. Scientists are thinking about using mesenchymal stem cells to help treat triple-negative breast cancer, the most deadliest type of breast cancer. In order for a stem cell transplant to happen, the donor and recipient must have a compatible human leukotype antigen match, also known as HLA. The recipient can usually find a compatible HLA match in someone with their family. If they cannot, there is a 1 in 10,000 chance of them finding a compatible HLA match. When the recipient does not find a compatible HLA match, their immune system will reject the implanted cells. This is known as immunological rejection. Doctors and scientists are trying to create suppressant drugs to trick the recipient's immune system into thinking those cells have already been there and they have not been implanted.
Throughout this project, my group members and I came up with 3 compelling issues. Number 1, starting with immunological rejection. Immunological rejection is when the stem cells are injected into the body and they are rejected. The symptoms of immunological rejection is a rejection process that happens when the stem cells are injected into the body and the immune system attacks them thinking that they are unwanted bodies. Symptoms of immunological rejection are flu-like or stomach bug-like symptoms, so you'll be throwing up, you'll be achy. So allograft rejection is the second compelling issue that we came up with. Allograft rejection is when the stem cells are injected into a specified organ and the specified organ goes through its own rejection process. Both of these rejection processes make it so that there's no new growth with the injected stem cells and they do not do their job further. Lastly is GVHD, which is shown on the screen. That is a reaction of GVHD, also known as graft versus host disease. Graft versus host disease is when the stem cells are injected into the body and the white blood cells attack them, which can result in rashing or swelling or inflammation. Also, problems in the GI tract.
Okay, so stem cell therapy could be the new version of organ donors and methods that take too long when patients don't have that amount of time. Scientists and doctors have seen that with stem cell therapy, when the treatment is injected in the body normally immediately rejects it, or patients have seen in the long run, weeks or months after the treatment, that their body has no changes, the treatment isn't working, all of that. So it ends up making a waste of their money. So our group has proposed that we make a prototype that has a base of green tea with extra things added in, like ginger, pomegranate, lemon juice, and turmeric that all have extra benefits and vitamins. This drink is meant to be used as something to help stimulate stem cells and to help out with the injuries inside the body that we can't get from outside the body.
Once funding is secured for our proposal, the first step will be to go into testing at the UVA Stem Cell Clinic. We'll test our beverage, Regenerate, to make sure it has the proper properties to help the stem cells. Once this testing is finished, we'll go into the production phase. Production will take place at 2 local breweries, the Lake Anna Cooling Ponds Brewery and the Log Home Brewing Company, both up there. We'll use each of these facilities for half a production day each month to produce the desired 3,000 gallons of Regenerate. Once it has been produced, it will be transported via trucking service to 3 stem cell clinics, 2 in Richmond and 1 in Charlottesville, where it can be distributed directly to the patients who need it. The first cost associated with our proposal is the testing at the UVA Stem Cell Clinic. Because of scientists' time, laboratory space, and expensive equipment, this will be an expensive phase. We are setting aside $100,000 for this initial testing, as well as $50,000 for further testing and refining. The rest of the proposal is monthly. Ingredients for each month of production will total to $12,000. We'll pay each of the facilities we are manufacturing it at $5,000 each month, totaling to $10,000 for manufacturing. The trucking service, which will distribute our product to the clinics, will be paid $750 per drive, which we'll need one drive a month to distribute it. And then lastly, $250 to each of the clinics for storage, advertising, and distribution of our product to the patients. The $1 million grant will cover our proposal for 3 years. If it is successful, we will be looking for future funding, maybe from UVA College, to continue our proposal.
As stated before, our proposal is a drink to help stimulate stem cells. The issue we're targeting with this is apoptosis, which is the decay of stem cells over time after they've been transplanted into someone. As they decay, it slows down the rate in which the body will heal, overall making the initial implantation somewhat useless. And our solution for that would be Regenerate, which would help to stimulate stem cell activity using all natural ingredients and would accelerate the rate in which we heal and provide long-term vitality. This is viable because it can be produced and distributed locally throughout breweries and clinics, as Samir had said, and it just makes it overall more affordable for people who have just gone through surgeries and implantations of stem cells, making it better for them in the long term.
Overall, thanks to George Mathey, we are able to locate stem cells inside of the body successfully. Overall, and there are some issues that come with that. The main one in particular being that, excuse me, the main one in particular being that the body is able to reject these stem cells once they are inside. Now, our proposal's plan is that we use Regenerate to recreate the cell's way of reproducing and overall staying healthy inside. Excuse me, sorry. After this will be put into effect after surgeries in hospitals. We want to put them in by just being there. Sorry, excuse me. Like I said before, our proposal is just to have it as an afterwards of a surgery. That way these stems are able to sit and stay and just kind of reproduce slowly. That way the patient is able to actually physically be stable.
We wanted to say a big thank you to Ms. Richardson, Mr. Hauschner, the BRVGS admin, and UVA for making this project possible. Thank you. Oh, our next slide is we're excited.
I don't know if the judge in the back would like some, but would you like to try some? All right.
Yes.
Any questions?
Great, love the idea. I gotta admit, I didn't know what I was gonna be handed, but I love the product idea. Tell me how you came to your ingredients list. Is there background research available that this seems to help with stem cell grafting, or walk me through this might be proprietary.
So it's okay, it's okay. So when I was first researching stem cell therapy, I was wondering what could help in the sense of stems being boosted, or like, is there any way to actually help these cells? But I came across natural ingredients like pomegranates, lemon, turmeric. There is something in turmeric called it starts with a T, but I don't really know the word for it quite right now. But I found a bunch of ingredients like skins of grapes, which I did not actually put in there, but
most types of tea, chamomile, green tea, raspberry skins, cherry skins, pomegranate.
This was in the literature you were looking into?
Yes.
Have there been history of orally administering and seeing it help? I know you guys have a research component. I'm assuming that's what the research is partially for, to kind of have success rates of this, right? This is genuine curiosity. Have you found anything about success rates on this product of yours before, something like it? Oral administration versus IV?
Not really. I mean, in my research, I came across like a lot of it was just transplants and it just had a lot of side effects and doctors were trying to create drugs to trick the recipient's immune system, but that's it. I've never seen anything about like taking medicine like Tylenol or something like that that could make it work.
But as the logo says, no needles, no pain, just regenerate. So the point being that this, while it's not like a one-off cure for these ailments, it's a way to help out that doesn't require a lot of expense and doesn't require real medical procedures.
I would also like to ask, did you guys like the taste at least?
Feel better already.
Of course.
Ladies and gentlemen, we're going to take a break as we are ahead of schedule. We will return to presentations at 10 after 11.
Good morning, everybody. My name is Ella. This is Grayson. Over there we have Jordan, Matthew, and Michaela. And this is our gut microbiome grant proposal.
The word microbiome refers to microorganisms, their genomes, and their surrounding environmental conditions. Microbiomes are everywhere around us in our day-to-day life. Microorganisms in these biomes all have specific niches built for their makeup and their own favorable conditions. An example of one of these niches may be influencing metabolism. For our grant proposal, we are focusing on the gut microbiome. The gut microbiome is first place in terms of bacterial density and second place to the brain in terms of nerve endings. The gut microbiome has been shown to regulate mood hormones such as serotonin and tryptophan, which is a connection between the brain and the gut. Another connection between the brain and the gut is the gut-brain axis. The gut-brain axis includes the release of transmitters that regulate secretory functions in the gastrointestinal tract.
Recent research in the microbiome field has focused a lot on personal medicine lately, and they're exploring how individual microbiomes can affect the human's responses to things like disease treatments and dieting. And there are studies that also link mental health to disease treatments and cancer therapies, and government and organizations like the National Microbiome Initiative are funding large projects to move forward in the field. And public awareness has spiked with more people becoming more aware of what they're eating and how their diet impacts their gut health.
The issue with our topic is that a clear definition of an average healthy gut microbiome has not been created by scientists. Many things can determine the health of someone's gut microbiome, such as exercise, diet, and lifestyle choices, but also things that aren't controlled by the individual. Some of these may include geographical location, environmental factors, and genetics. Overall, this is an issue because without the definition of an average healthy microbiome, scientists cannot provide consistent, clear research to the topic.
Our plan is to encourage individuals around Virginia to help the medical field with microbiome research. We need to, like we said, we need to determine what a healthy gut microbiome looks like in order to continue research. To do this, we're proposing that we use fecal samples sent in to research and determine what a healthy gut microbiome looks like. To get an idea for cost, we reached out to a doctor at UVA and she provided us with this image. She explained that the cost would differ depending on the way that we characterize the data. If we had decided to go with the bottom option, metagenomic sequencing, then we would have characterized the entire genome of every species in the gut, and this would have been far more expensive. Instead, we decided to go with the top option, amplicon sequencing. This is characterizing a small portion of the genome of every species in the gut, and this is far more cost effective so that we can have a larger sample size. This research has been done before, but not in like a specific and applicable form, because it's been shown that microbiome health differs depending on the way, or depending on geography, diet, and lifestyle. So if we limit our region of study to Central Virginia and research diet and lifestyle beforehand, then we can get a good idea of what a healthy gut microbiome looks like under these circumstances.
The study will begin July of 2025 with Gut Feeling, our company, joining county Facebook groups across the state in order to promote the study. From there, posts will be made every 2 weeks with the leading up until the questionnaire, which will open 1 week before each collection phase. This week buffer gives participants time to fill out the form, as well as the company itself to review each submission to see which ones would be beneficial for us to use. After participants receive confirmation that they have been chosen, the kit will be packed up and mailed out to them, where they will then complete it, pack it back up, and place the prepaid shipping label on the box, drop it off at their nearest FedEx location. Then those boxes will be mailed to UVA Research Laboratory, where actual sequencing and diagnostics will be done by research fellows, grad students, anyone who really works in the lab will be doing that for us. Then participants will receive their results through UVA MyChart, and a $5 Amazon gift card will be wired electronically. Gut Feeling will also provide 3 employees on site, make sure logistics and everything is handled correctly, and there's no miscommunication between participants and researchers. So the first portion of our budget is the UVA Research Laboratory Director salary, which just covers the cost of the use of the lab, the technologies within those. The second portion is the initial shipping out to the participants, and then the third portion is them shipping it back to us. We had to pay extra for express shipping because we think about how long stool samples keep. Then we have specimen cups as well as secondary containers, which are just airtight, air and watertight resealable bags to make sure there's no leakage during anything. Then we have paper costs, which is a standard 8x11 piece of paper cut in half with instructions on one side, prepaid shipping label on the other. There's ink cartridge costs, which is just the same inks that the schools use, we just plan on using those. And then we have the $5 Amazon gift card that will be given to participants for their participation, as well as the sequencing cost, which is just the salary of the 3 on-site employees.
The process of the sampling itself is going to be our main outreach to our participants. It will begin with an online questionnaire that participants will fill out to help us determine diet and lifestyle choices beforehand. This will help us make the most of our resources. You can scan our QR code and fill out the questionnaire if you'd like to. Then once all the questionnaires have been filled out, the participants will receive a box like this one. This will be where the sample is kept. It'll include the box, the specimen cup, and the instructions. The instructions will be for use and for mailing. For mailing, there will also be a pre-printed shipping label, so there's no cost to participants for their research. We want our participants to feel as comfortable and excited about this opportunity as possible.
We should be funded because of the need for more research in the field. Microbiome research is currently lacking in information and needs more long-lasting results. With the connection between the host's health and the gut microbiome, finding a definition for what a healthy microbiome is important. If we find the definition of a healthy microbiome, we have the possibility of getting more treatments for illnesses such as anxiety, type 2 diabetes, rheumatoid arthritis, eczema, and even some cancers, which are all caused by an unhealthy microbiome.
We want to thank Dr. Cowardin from the University of Virginia for responding to emails that were sent to her and helping us determine the prices and budgeting of our project.
These are our references. Are there any questions?
So for those in the audience and those listening at home, we've got a stool sample kit here with a biohazard bag, and in addition to my stool sample cup, it looks like you guys sent us one already with some sample in it, because here is our Hershey Kiss. Very cheeky. Are you going to choose?
So the questionnaire, the questions, I don't know if y'all looked at it specifically, but they ask questions about lifestyle, pre-existing factors, where you live now, where you were born. And we plan on choosing a wide range of people. That way we don't get all results from the Richmond area, because that wouldn't be the average of the Virginia microbiome.
And then you mentioned you're going with the amplicon, no, what was it? The amplicon sequencing over whole genome. Did you consider the whole genome at all? Why the amplicon sequencing?
We did consider the whole genome, but it was just kind of an unnecessary amount of research, because it sequences the entire genome of every species in the gut. And this was just so much more expensive, and we didn't need all that information. So we went with a portion of the genome instead.
Hi, I'm Madeline. This is Luke. That's Maddie, and that's Jack. And this is our presentation about funding community gardens and functional foods. Functional foods is a vague term, and it's not totally agreed upon for everyone. But it was originally introduced in the 1930s by the Japanese government to describe processed foods that contained that supported biological functions in addition to being generally nutritious. Some example of these functional foods are roots like ginger and turmeric, but they also include foods that are more generally known for being healthy, like fruits and vegetables, as well as foods like honey, soybeans, and chia seeds. Current actions and events regarding functional foods typically revolve around seeing how they can be used to advance human health and further it, as well as seeing if they could potentially be used as some sort of substitute for modern medicine. Typically, testing like this is done by seeing how a specific functional food, like honey or ginger, affects a particular aspect of human health, like acne or obesity.
Healthy foods are increasing in price, which is leading to increased rates of obesity. Many families are buying processed foods because they are cheaper. Our group wants to fix this by lowering the cost of functional foods because many families don't have the option, so they don't really have much of a choice. Our group is building community gardens in governor school counties, which will provide health, fresh, and cheaper foods and teach people about the benefits. Our group chose to build community gardens in governor school counties to help prevent obesity, increase the access to organic food. We will grow functional foods like fruits and vegetables and teach people about gardening and nutrition. We believe people be more likely to grow, eat, and learn about fresh food if they are involved in a community. And we will partner with Evergrow to help achieve sustainability and availability.
Our community gardens consist of a three-phase plan. The first phase is preparation. We're immediately going to buy an acre of land from each of the governor school counties. We're going to clear each acre of land by van for transportation. And so we're going to prepare these gardens. We're going to buy the necessary materials for these gardens. We're also going to have volunteers come help and construct the greenhouses. There's going to be DIY greenhouses and DIY sheds. So you're going to have volunteers help construct them. And so phase one of our plan is mostly just preparation. Phase two is use. So for the garden, we're going to be having classes in our classroom. And the classes are going to consist of nutraceuticals, what they are, and misconceptions about them. There's also going to consist of a class on functional foods themselves, macromolecules, what they are, and just how functional foods can benefit the body. And use also consists of selling the plants grown in the garden. So community members will come and they will grow the plants and they will be able to reap their benefits by selling plants for profit for our community garden. And the third phase of our plan is long-term effects. We are going to monitor relevant data from departments such as the Virginia Department of Health and also the CDC for data based for obesity. And we're also going to monitor food prices in the areas of governor school counties. We're going to monitor prices from Walmart and from Food Line to generate data based on how much the food is costing in the area. So this is our budget. There is the initial cost and the upkeep cost, which is over 10 years. So the upkeep costs contain like renovations, and also maintenance, gas, stuff like that, and then there's the total cost at the end. So obviously 7 acres of land, we're clearing each acre of land, and then a van for transportation for garden materials. Next are the greenhouse and the metal shed. These will be used for storage. The greenhouse will be used for planting more sensitive plants, and the metal shed will be used for materials. Gravel will be purchased for the classroom and for the parking lot. Picnic tables will be purchased for the classroom. AV apiaries, also known as bee houses, will be purchased for the classroom, which is honey is also a big functional food. We'll buy materials for the garden, such as wood, nails, more stuff like that. Soil, obviously, to plant the plants in. Seeds, tillers, and sprinklers, obviously very important for a garden. And that leaves the total initial cost at $386,750, with the upkeep cost over 10 years as $41,700, which makes the total cost for our community gardens $428,450.
So this is our demonstration of the proposal. This right here is our greenhouse. This spans about 4,000 square feet. These two are our sheds. They are each 2,500. No, I'm sorry about that. They're each 720 square feet, along as with the three small gardens. Our four large gardens, our parking lot, and our indoor classroom, they're each 2,592 square feet. These two are stores, our farm stores. They are 500 square feet each. The greenhouse will be used for planting small plants in the wintertime so we can get a head start on planting so the frost doesn't get to the plants out here. These gardens will be used for planting larger plants, and these will be used for smaller plants. These are where we'll sell all our plants. So we'll make most of our money from here. And then this parking lot holds up to 16 cars. And this is where we'll teach most of our people how to plant, water, and take care of all the plants. And these will be where we keep our tillers, lawn mowers, anything that we need to keep this running.
Now you know that the high cost and healthy foods leads people to choose cheaper and more processed options, which contributes to the rates in obesity in the U.S. Unfortunately, many people find it easier to buy fast food than it is to invest in healthy, nutritious meals. As of 2019, about 47 million Americans face hunger every day, including 1 in 5 children, and it's still on the rise. However, there is hope. With our community gardens, we plan to make fresh, affordable food more accessible to our communities and eventually the world. With the help of Evergrow and our communities to provide manpower and supplies, we plan to make the world a healthier place, and this is why you should invest in our gardens.
I was just hoping for a little clarification on you're gonna have community gardens for perhaps underserved communities,
Yes, sir.
Are you gonna have them eat it, or are you gonna have them sell it?
So we'll have them eat it and sell it. So we'll have the people come that hold the community garden and take care of it. They'll get a lesser price on everything. And then we'll also, to keep the uphold of the garden for the remainder of the year, the remainder of the years that we plan to keep the garden running, we'll sell the food. Yes, sir.
Hello, the topic that we will be discussing to you today is economic benefits of wilderness conservation. The economic benefits of wilderness conservation broadly refers to the economic benefit of protecting wilderness areas in our world. As of now, many wilderness areas are being destroyed for the simple fact that it makes money. So as a group, we intend on bringing an economic benefit to these wilderness areas without the destruction of them. This not only protects the environment, but also makes economical sense. Many actions have been taken to protect and spread knowledge about wilderness areas. Things such as different camps, groups, and programs strive to spread knowledge about wilderness conservation. In fact, the U.S. has enacted the Wilderness Conservation Act of 1964, which protects national parks as wilderness protected areas. And that basically means that these protected areas are illegal to be tampered with, and if they are, it can be illegally charged. However, these government acts and many other actions can only do so much in the grand scheme of things. Things such as deforestation, animal endangerment, and pollution are still ongoing and currently increasing as the time goes on.
Our main issue is that people are not well informed on the conservation of how to protect and conserve wilderness areas. As wilderness areas are being taken down, people are not as informed, which we would like to inform them on how to do so. In 2023, 1.15 million hectares of forests were cut down, which was impactful to which the CO2 levels were being lost, which is equivalent to 548 million CO2 levels being lost. And the CO2 regulates our Earth's temperature and is important for us and the environment in order to survive. For our proposal, we want to build a camp in order to teach adults how to become eco-tourist guides. They will go around and show people how to essentially teach them about the wilderness areas in Virginia, while also informing them about them and teaching them how to protect them in a safe way and to conserve them in a safe way. Ecotourism is a nature-oriented program which will essentially it reflects on preservation and conservation, which will teach us how to preserve and protect. And by 2035, it is projected that $561 billion is getting money to the U.S. By ecotourism. So we are asking for a $1 million investment in order to do this. It will be used to run and build a camp in order to teach ecotourism.
Our camp will start at 7 a.m. with breakfast at the dining hall, and then campers will go to their classes from 8 a.m. to 12 p.m. and switch classes at 10 a.m. At 12:30 p.m., the campers will go to the dining hall for lunch until 1:30 p.m. At 1:30, the campers will get on the bus and go to the nature preservation area until 4 p.m., having hands-on experiences with the wilderness. At 4 p.m., the campers will get back on the bus and go back to the campsite and have free time to do whatever they need and shower until 5 p.m. At 5:30 p.m., the campers will go to the dining hall for dinner, and at 7 p.m., the campers will be able to hang out at the outdoor fire observation area. In order from most costly to least costly, the things we will need for our camp
are cabins, classrooms, a dining hall, cooks and servers, a bus driver, teachers, janitors, a shuttle bus, and an outdoor fire pit. We hope to have 36 campers per 2 weeks of camp, and the campers will be charged $500 per the 2 weeks of camp. This will bring in $18,000 per 2 weeks of camp, and we will use that money to pay for each worker's salary, and we hope to build an office building after a few years of operating.
Our camp is called the Eco Guide Camp, and each building will be made out of oak and birch wood and will take 150 to 250 logs per building. On the top left are the 6 cabins, and each one is a 30 by 30, which is around 900 square feet, and the bathrooms will be a 15 by 15, which is around 200 square feet. In the cabins, there will be 6 beds, 6 nightstands, and 6 wardrobe closets, and in the bathrooms, there will be 2 showers, 2 toilets, and 4 sinks. On the top right, there are 2 classrooms, which are a 32 by 32, and it's around 1,000 square feet, and will have 18 desks that will hold 18 students and 1 teacher. The dining hall will be a 35 by 35 and will be 1,200 square feet, and will have 9 picnic tables that hold 4 people per table, and the kitchen will have 2 ovens, 2 refrigerators, and plenty of counter space to prepare the food. The fireplace will be a 10 by 10, which is 100 square feet, and will be surrounded by stone seating. The camp will be next to Barusa State Forest, which is where the students will put their skills to the test that they learned throughout the 2 weeks, and it will also be next to Smith Mountain Lake, which is on the bottom left. Our project should be funded because our camp teaches adults how to safely guide tourists through the Virginia mountains and lakes while still following the laws that have been put in place to help the wilderness and wildlife stay safe while also maintaining the nature's beauty. This is our work cited. Are there any questions?
So you are training people who want to be ecotourism guides.
Yes.
Do you have like a tour company or something they'll work through after that, or are they going to go off and like take their own ways and try and start their own company?
We didn't really have like a company they would go to. It's mostly just so that there are more ecotourism guides like in Virginia.
Thanks so much.
Good morning, everyone. My name is Emma. This is Colton. This is Colin. This is Thomas, and this is Molly. And this is our presentation on vertical farming.
Sustainable agriculture goal is to produce food enough for the world and its needs. Our way to meet that goal is vertical farming. Vertical farming is a process of growing plants stackable vertically. The reason why vertical farming is used and is very important in biotechnology is because vertical farming is a highly controlled environment that can be used to produce desirable traits that researchers want, and researchers can also research the traits. Current actions that the government are taking they are enforcing programs such as enhancing ecosystems, funding research, and funding farmers. Concerns of the environment is that the environment can be hurt by industrial farming, and the environment can also be caused due to chemicals being released.
The most compelling issues we've run into is consumer acceptance and skepticism. Many people are unsure about vertical farming and may see it as a reason to choose traditional agriculture products over ours. This can lead to mistrust and unfamiliarity. Consumers wonder if produce grown through vertical farming has the same nutritional content as traditionally grown agriculture. Studies show it does, but there is still skepticism. Vertical farming is our future, and this has been brought to our attention because of it. We can fix this uncertainty and skepticism by teaching people about it and letting people volunteer at our warehouse.
Our proposal is a vertical farming facility. This facility is located in Broadway, Virginia, and it's 11,800 square feet. In this facility, we will have vertical farming systems that are placed along the walls of the facility, and they will be put in the middle of the facility as space allows. So these vertical farming systems contain shelving, which is 4 rows high and 10 feet long. On these shelves, planting bins will be placed, and in the planting bins, compost will be put. We will grow plants in these planting bins, which include greens like lettuce, kale, and spinach, as well as a variety of herbs and other commonly used crops that will cycle throughout our facility. These plants will get water and nutrients from an aquaponics system, and they will get their light from LED lights attached to the tops of the shelves. Our staff of this vertical farming facility is the volunteers of the Master Gardeners program, as well as students in the horticulture class at Bridgewater College. And the plants that will be grown in this facility will be distributed into the Shenandoah Valley region.
Per year, on average, the Virginia farm makes 175.8 bushels per acre. We plan to match this number with less space being used due to the space efficiency of vertical farming. We plan to meet this goal within 2 years, with the first year being to buying the facility and repairing the facility and training our volunteers. This is our budget. We were given the budget of $1 million Our budget is separated into 3 groups: the building costs, the utilities, and overall setup of the vertical farming system. Firstly is the building costs. This is made up of buying our building, repairing our buildings, and plumbing. Secondly is our utilities costs. These are costs which are paid monthly and include water and electricity. Due to our aquaponics system and lastly is our overall setup costs. LED lights, aquaponics, although this is our budget, this is our $1 million budget for our monthly costs.
So for our prototype, we created a simple demonstration of a vertical farming system. So this shelf is 5 rows high, and each shelf is 8 inches by 14.5 inches. On each shelf, planting boxes were placed, which are 9 by 6 inches and 2 inches deep. Compost from my home was put into these planting boxes, and each box contains 12 plants. They're in 3 rows and in 4 columns. LED lights serve as the source of light for these plants, and the first 2 shelves are actually working. The last 3 are just for demonstration purposes. So on the first shelf, beets are growing, and on the second shelf, spinach is growing. The beets didn't grow very much at all, and then the spinach actually sprouted a decent amount. I can kind of show you. The beets not growing could definitely be due to my fault. I do not have a green thumb. I'm not very good with plants, but I really did try for this project. And because this is such a small scale of vertical farming, I couldn't figure out a way to incorporate an aquaponics system, so the plants were just watered manually as needed.
In conclusion, we recognize the fact that major farming land is being taken and transformed into modern-day houses and buildings. Due to this, we chose vertical farming as our option to increase agricultural productivity and not run into the issue of loss of open farming land. We hope to increase productivity and to produce more cost-efficient fruits and vegetables for local families in Central Virginia. We hope that our facility can also help educate people and offer hands-on experiences through volunteering throughout the College of Bridgewater. These are our references.
That's everything.
I had a quick question. If your vertical farming facility place agriculture, or is it working?
I would say that we would want it to work like together because we mostly decided to choose vertical farming because there's so much land that's being taken and buildings are being put on it, so you can't really go back and farm on it once there's buildings there. So we were hoping to use already in place buildings to help produce.
It'd also be cool. Vertical farming could be happening in an ideal world. That land. Are you guys planning on selling the produce kind of a private firm or a farm? Is this outreach in a community garden, or is it going to be what's the plan for this?
So we plan for this produce that we produce to be distributed throughout the Shenandoah Valley. Because like it's such a small facility, we're not going to be able to reach like all of Virginia, but we just want to produce more crops, as many as we can, because that is such an issue right now. We're a growing population, and we need to produce more and more crops, and that's why vertical farming is such a great thing because it takes up less space and it's very efficient, and you can make so many more crops with it.
When you say distributed, do you mean like
Sold.
Okay. We're good to go. Thank you so much, guys.
All right, ladies and gentlemen, your attention please.
Hello, I'm Addison. This is Tegan, Isabel, and unfortunately Anders could not make it today, but this is our presentation on gene editing.
Gene editing is the modification of a specific targeted strand in DNA. There are many different proteins used in gene editing, but over the history of gene editing, the most advanced technology we have found is a protein called CRISPR-Cas9. The protein was discovered by Jennifer Doudna, and she was very fascinated on how the CRISPR-Cas9 protein was able to fend off viruses, and she proposed that we use the protein to do the same, but with specific targeted DNA areas that we have in mind. Currently, the most technologically advanced protein used in gene editing is CRISPR-Cas9. This protein is the most current and most modified and is used in most modern gene editing experiments. The CRISPR-Cas9 revolution started in 2012, and this kickstarted technological advancements in gene editing, and overall, it made gene editing much easier as it was more advanced, and it was much easier to work.
Our compelling issue regarding gene editing is the lack of education on the topic. Many people believe that gene editing is ethically wrong due to the public spreading misinformation, such as designer babies. These harmful terms can cause the public's opinions to change, leading to a decrease in education and engagement on the topic. If more people knew what gene editing was, then there could eventually be the development for treatments for diseases such as cancer. Our group decided that the most important next step for gene editing in local communities would be a workshop for science teachers dedicated to teaching gene editing information. Our proposal consists of a 2-week research experience that will be conducted twice at the University of Virginia. It would also have 2 lab workers assisting the science teachers. Our prototype specifically is the lesson plan that science teachers will be taking and implementing into their classroom curriculums. In order to make the workshop engaging, science teachers will be conducting a gene editing lab that utilizes CRISPR-Cas9 technologies to remove the GRF9 gene in Arabidopsis thaliana plants.
For our logistics and timeline, we plan on having a 2-week research experience for teachers program that will be held at UVA from June 1st to the 14th, July 7th through the 21st. 20 teachers and 2 scientists from UVA will be attending. During their stay, all lodging, meals, and transportation will be provided free of charge by aligning at UVA meal tickets and charter buses. As part of the course, a 2D lesson plan will be provided to teachers for them to incorporate into their curriculum. In addition, once the course is completed, each member will receive a $2,000 stipend to thank them for their time.
Our budget is a total of $484 per wet red experience, and that is broken down into the room and board, stipend, lab space, charter bus rental, and the gene editing technology price. For room and board, it costs $1,550 per person, and since there will be 20 teachers, that will cost $23,100. For the stipend for the teachers and scientists, that would be $2,000 per person, including the scientists, costing $44,000. The lab space is $10,000 per person, so $200,000. The charter bus rental per day, which is to UVA at the start of the 2 weeks and from UVA at the end of the 2 weeks, costs $3,500 per day, which would cost a total of $7,000. Gene editing price for Arabidopsis thaliana is $105,000, and since we use twice for per 10 teachers, this would cost $210,000. Because this will be repeated twice, this will cost a total of $968,200. Our prototype is the 2-day lesson plan, which is to be implemented into classrooms upon completion of the 2-week RET plan. In this packet, on the front is the lesson plan for the first 6 pages. That's the lesson plan, the teacher's copy of the worksheets, and then the worksheets themselves. The worksheets are optimized to be printed out and given to the students, while everything else is optimized to be projected onto a screen like this one. The following 11 pages are notes and warm-ups, which are to be printed out to be projected in a lecture style way in the classroom.
We are requesting $968,200 for our 2-week RET program over the summer and an in-class lesson plan about gene editing. We should be funded because introducing gene editing in the classroom clear up any misinformation that students may have. In the future, this could lead to more favorability about gene editing, which could then lead to cures for deadly genetic diseases being produced faster, safer, and more efficiently. Thank you.
So we're excited. Any questions?
Where are you getting your
There would be an interest survey theoretically sent out to anyone interested, and these teachers, pretty much all biology teachers in the region, would be able to go.
So tell me about the actual workshop. If I were sent to your workshop, what would I experience? What would I do? And what would happen?
So the lab will take course over 2 weeks. It will be an Arabidopsis lab where a certain gene is removed and another one will be implanted. And over the course of the 2 weeks, there will be many activities such as like crossword puzzles, quizzes, lessons about gene editing, and there will be checkups on the Arabidopsis plants. And at the end of the 2 weeks, results will be compared and analyzed.
I don't know if you guys are familiar with the plant life. Tell me why you chose Arabidopsis.
I chose Arabidopsis because it has a very short plant life, so it can grow pretty fast and results can be seen quickly.
Okay, that concludes presentation.